welcome back to our geometry videos. Here, we're still in Unit 2, and we're now on problem number 31. Again, some more algebra type stuff. Right here we're solving a system of equations. And so it says, the set of equations below is an example of a system of equations, right? Two equations, two unknowns. The first part wants us to graph it on graph paper. Okay, so I've done that on the internets here. So here's a graph of the two equations, y equals negative x plus 1, so here's our slope of negative x, intersecting the y-intercept at 1, and then here's 2x plus 7, so the slope of positive 2, intersecting up there at 7. And here's the point we're interested in. This is the intersection point, right, which tells us graphically right there is negative 2, comma 3. So this is a graphical representation of the system of equations where the intersection of those two lines is negative 2, comma 3. So let's write that down as what we got. Okay, graphing them is nice, except sometimes the solution doesn't fit on maybe the graph paper, or the point of intersection is kind of ambiguous. We don't really know if it intersects at an exact point or it gets off. If we were just to look at that, you know, how do we know it's really at negative 2, 3? Maybe it's at negative 2.02 and 3.1. So it's hard to tell just from a graph where the exact value is where it intersects. But it's nice because we know our answer should be somewhere around there. So to find the exact answer, we want to solve it algebraically. So if I know both of these equations are equal to y, then they have to be equal to each other. So if y equals negative x plus 1 and y equals 2x plus 7, then negative x plus 1 equals 2x plus 7. I'm going to subtract 1 over to this side, so negative x equals 2x plus 6, and subtract 2x over to this side, so negative 3x equals 6. And we divide both sides by negative 3, we get x to equal negative 2, which is what we got up there. So things are looking good. Now that we know that x is negative 2, we could plug it back into either one of these equations. I'm going to plug it into this second equation. So y equals 2 times negative 2 plus 7, which is negative 4 plus 7, which is 3. Which matches what we got with the graphical, so that worked out pretty good. So graphically gives us a good estimation of where it's at, but doing it algebraically gives us the definitive location of that solution of the system. If you have any questions or comments about how we graph a system or solve a system, leave a comment. Otherwise, feel free to like, subscribe, or share our videos.